Did the presentation come up?
Yep, sure has.
Okay. Thank you all for your time and attention. My name is Todd Wilbur with Precision Explosives, and today we're going to talk a little bit about explosives. We're going to do kind of a deep dive into what makes up explosives. Please stop me if we go too deep into any topic or it sounds like it's just a bunch of scientific gibberish. A bit about my background. I'm a former U.S. Army Delta Force bomb technician. I've also been a contractor. I've worked in Afghanistan, Iraq, and various places all over the world. I've worked on hundreds of IEDs by hand and disposed of tens of thousands of pounds of explosives, mostly homemade explosives. I've also worked in academia. I'm an adjunct professor at New Mexico Tech, and I've done some original research there on various types of homemade explosives and direct the research of some of my grad students. So I'm going to share with you some things that I've learned from some really smart people and share some things with you I've learned from firsthand experience and then having to dig through others' research to kind of figure things out. We're going to talk today about base explosives and characteristics, compound explosives, propellants, and then lastly, homemade explosives. I'm not a dog guy, but I can tell you what is off-gassing from explosives. I can tell you the components of those explosives. You need a dog guy to tell you how to condition the dog and look at the behaviors and so forth. That's not my forte. So if I start to sound like I know something about canines, I don't from that standpoint. So I'm not going to try to field any questions related specifically to dog behavior, but we're definitely going to do a deep dive on explosives. Let's talk about the base explosives. I consider these the foundational explosives because basically everything else is made from these three explosives. When we're talking about military and commercial explosives, when we start talking about what is in the each of these explosives, it's important to understand that not all of these things are pure. In fact, most cases, your explosives that you think are pure explosives are not. For example, you see here 2,4-DNT, that is considered that like the skinny sister to TNT that is almost always, well, in the manufacturing process, it will always be present. It actually has to be chemically stripped from TNT so that you're left with pure TNT if that's what you want. So that is actually what your dog is really hitting on. It has a much higher vapor pressure. It's far more prevalent. It's 10 to 30 times higher in concentration than regular TNT. However, something to be aware of is that Russian TNT does not contain any DNT. So one of the ways you can tell whether or not DNT is actually present is by looking at the color of the TNT. You notice in that picture, that is about a ½ kilogram of Russian TNT that was used in an IED that I worked on in Afghanistan. Notice that it's very red in color, almost like a brick red. That's indicative of almost pure TNT or pure TNT. In fact, one of our products, the odor print, you can tell the age of it because it starts to turn pink. That means that the DNT has left it, and now you're left with just TNT. I hope I haven't confused anybody with that. Also, things like RDX, explosives like RDX, in the manufacturing process of RDX, HMX is always present. You can make HMX and chemically strip away RDX, but you'll always have HMX present. The difference between HMX and RDX is very small. And basically, if your dog is imprinted on RDX, your dog will find HMX. So I wouldn't worry about those too much. Everything else is going to be made up of combinations of these with plasticizers and other binders and so forth. Does anybody have any questions about that? Because it's a really foundational element to what we're going to be talking about. Any questions? Okay, so let's talk about some of this other, we'll call them complex explosives and how they're made up of what I was just talking about. So here we have those cornerstone, those constituent explosives of PETN, RDX, and TNT. If you have Semtex A1, H10, it doesn't matter. They're all going to be made up of PETN and RDX. Composition A5 is mostly RDX, but it has something else in it. Composition B3, TNT and RDX. Composition C4 is RDX. Cast boosters are TNT and PETN. HMX again, it's gonna be basically the same as RDX. As we start talking about other types of propellants, like for example, gunpowders, all gunpowders, all black powders are going to have a foundation oxidizer, and we're going to talk about that in a little bit. But all double base propellants are going to have either nitroglycerin or DNT. And then when we get down into commercial explosives, you're going to either have nitroglycerin or ammonium nitrate, but we'll talk about those in a minute. Any questions there? It's important for us to understand, especially when we start talking about some type of detection method. In this case, we're talking about a biological detection method with a canine, what the vapor pressures are of different explosives. This is a relative chart. It's not quantitative, but it gives you the relative vapor pressures of some common explosives or components for explosives. Notice TATP has a very high vapor pressure. Nitroglycerin has an extremely high vapor pressure, and that's something we need to talk about as far as packaging and storing and handling, that sort of thing. Then you get down here to TNT, PETN, RDX, and then HMX. An interesting little aside, HMX is most people think it's Her Majesty's or His Majesty's explosive, but it's actually high molecular weight RDX. That's what HMX really stands for. So these are relative vapor pressures, and this is important for us to understand when we talk about what is it your dog is actually detecting relative to different types of explosives. When we start talking about our complex explosives like C4 and Semtex, one of the things to understand is that, again, these things are not pure. They have other things in them as part of the manufacturing process. For example, with C4, you have the most dominant odor in C4 is a chemical called cyclohexanone. And here in the United States, if I put out pure RDX and put out cyclohexanone, most of the time, I'd say probably 97% of the time, the dog will run right past RDX and go to cyclohexanone. It has a huge vapor pressure. It makes up most of the headspace. There are some other things like binders and oils that make up the other 19% of that headspace. And headspace is basically the stuff that's off-gassing off of the explosives. The RDX is only 5%. So it's really important that the dog get imprinted properly on RDX and not on something like C4 or Semtex, because they will walk pure RDX. If we get to Semtex, again, they're mostly made up of PETN and RDX. They're just going to be different ratios, different colors to indicate which particular flavor of Semtex you're dealing with. Any questions with that? All right, y'all are doing really well keeping up with this. We talked about what makes up the smell for C4. To kind of put it in terms that to me really mean something, if we look at taking vapor pressures and so forth and concentrations in positive numbers that I can kind of wrap my head around, we have C4, we have the tagant, we have RDX, we have the tagant, and then we have other things like cyclohexanone. If we put positive numbers on those, cyclohexanone is 666 billion, 600 million. The tagant is only 207,000. And lastly, RDX, the odor that we're really looking for, is only 231. So it's really important that we make sure that the dogs are imprinted on a pure explosive, or as pure as we can get, when we start talking about, well, can my dog detect all the different varieties of RDX or PETN or TNT? Gunpowders. Gunpowders are really important to us because a lot of IEDs, no matter where you are in the world, are made up of gunpowder. It is nothing for anybody, especially here in the United States, to go down to the nearest hardware store, pick up some already threaded pipe, throw some gunpowder in it, and then cannon fuse, voila, you have a bomb. It's not a very good bomb, but it's still a bomb and it can still hurt people. Smokeless powder. We kind of alluded to this earlier, but we're going to go into the specifics now. Smokeless powder, all smokeless powder has nitrocellulose in it. They will either have nitroglycerin or DNT in it as the other energetic component, making it a double base powder. Next, they're going to have binder and stabilizers. In black powder, all black powders have potassium nitrate in it. Some, like Pyrodex, will include something like potassium perchlorate, which is another oxidizer, but they will all have potassium nitrate. And the moral of the story is, look, you need to really focus on potassium nitrate to cover all black powders. And then if you look at some very specific types of powders that have high concentrations of nitroglycerin and DNT, then you get your dog focused on exactly what they're supposed to be looking for. In the United States, we have over 800 variations of double base smokeless powder, but we pick out 2 that have high concentrations of nitroglycerin and DNT and work dogs on that, and they do extraordinarily well. They can hammer all the smokeless powders. The 2 dominant odors in double base, as I said before, nitroglycerin and 2,4-DNT, the same thing that's found in TNT. Now, post-ignition, I'm not sure how much of an emphasis there is where you are on being able to find weapons or spent shell casings. Post-ignition, so after the gun has been fired, the stabilizers remain. In fact, lab tests have shown that the stabilizers will stick around for over a year. So if a dog is imprinted for gunshot residue on those stabilizers, you'll have a very high probability of that dog being able to find any shell casing or any gun that you toss out there, no matter what type of gun oil you used, what type of propellant was used. It's the stabilizer. That is the core, that's the key to being able to find spent shell casings and discarded weapons. Any questions there? All right, homemade explosives. Everybody loves homemade explosives, and everybody gets really excited about it because it seems like it's, there's endless number of possibilities. And that's true. There are basically an endless number of possibilities because in most cases, homemade explosives are made up of fuel oxidizer mixtures. So if you think about what it takes to make fire, you have to have fuel, wood, a match, whatever, and then you have to have atmospheric oxygen. In the case of homemade explosives, what we're doing is mixing the fuel and oxygen in the form of another molecule, like for example, ammonium nitrate or potassium chlorate, and we're putting those in intimate contact with that fuel. All we need now is enough energy to get those 2 to work together. That's the basis of fuel oxidizer mixtures. Ammonium nitrate is found in fertilizer. It's also found in instant cold packs. It's very easily obtained, and in most places, even in Afghanistan, and it makes a great oxidizer for explosives. Potassium chlorate sounds like a real cool chemical name, but it's most commonly found in match heads. If you can actually take a box of matches and run your dog on it, and it's actually a good source for if you just something, if you don't have a good training aid right at hand. And these are the most common things found globally. There's some others. It's very important to understand that those mixtures that I'm talking about, no chemistry takes place. Nothing happens where something becomes a new molecule, where you mix things together and all of a sudden it's something else. You can actually split those 2 components apart again, and you still have ammonium nitrate and a fuel like aluminum powder. What's different about the next 3, urea nitrate, TATP, and HMTD, is chemistry does take place. These are homemade explosive mixtures. Urea nitrate is found very common in Iraq, in that region, and chemistry does actually take place. You take urea fertilizer and it becomes a whole new animal. Same thing with TATP and HMTD. Some people think that you can run your dog on just hydrogen peroxide and that covers the peroxide-based explosives. That's not true. There is no hydrogen peroxide present in the headspace for those explosives as the off gas. It is a completely different molecule. Hopefully you'll never run into the peroxide-based explosives. They are very sensitive and they're very dangerous. Fortunately, you shouldn't find them in any large quantities. Lastly, are hydrogen peroxide and organic matter, sometimes called HPOM mixtures. HPOM mixtures use concentrated hydrogen peroxide. And when I say concentrated hydrogen peroxide, in the States, we can get at the pharmacy, we can get hydrogen peroxide at like 3%. Other places in Europe, maybe in Australia as well, you can get 6%. So when we talk about concentrated hydrogen peroxide, we're talking about levels at 50 to 70%, which would cause really bad burns if it comes in contact with your skin. But you mix those higher concentrations of hydrogen peroxide with something like Tang, and then you end up with an explosive, which, by the way, was the explosive mixture that was supposed to be used in the London 2006 airliner bombing campaign. Fortunately, they got thwarted. But the interesting thing about hydrogen peroxide and organic matter mixtures is that with a high enough concentration of hydrogen peroxide, you can take anything that you can eat or burn and make it into an explosive if you know the right ratios. So very aggressive oxidizers can cause real problems for us. Any questions there? All right, so we talked a little bit about homemade explosives and fuel oxidizer mixtures. I'm going to show you some examples. This particular example is from a 7.5 ton seizure that my team and I participated in with Afghan intelligence services. When I say my team, I was embedded with Afghan nationals in a safe house in the city. I had really no contact with Westerners except for when I turned in evidence. So we did a lot with Afghan national security forces and intelligence service. Here we have 7.5 tons. All of these containers are factory sealed and labeled, but they all contain homemade explosives. On the inside here, we have ammonium nitrate prills, which, by the way, are legal in Afghanistan. But we have ammonium nitrate prills mixed with automatic transmission fluid. This one's really surprised me. I never thought that you could use automatic transmission fluid as a fuel source, but it actually works really well. And when I do demonstrations, I actually love to use ground up ammonium nitrate prills and then automatic transmission fluid. It has a pretty good pop to it. Here is another interesting example that I really didn't suspect. And here you see a color test kit that shows positive for chlorates. In this particular case, it's potassium chlorate, coming from the fireworks industry, probably out of China or Pakistan. And here they have mixed corn oil with it. And corn oil is extremely prevalent in that particular region, actually anywhere in the Middle East as well. You'll find 5-gallon containers of it everywhere. On the backs of motorcycles, it's very common. And mixed with potassium chlorate, it makes, again, a pretty good explosive. I like to use that one as well in demonstrations. Here we have one that took me a while to figure out whether or not it would work. And only after reading some basically how-to books by Al-Qaeda did I understand what the ratio needed to be for this. And this is potassium chlorate again and cornmeal. And this does actually explode, not the way they prepared it here, but in the right ratios. And if the potassium chlorate is ground up and mixed well, you do actually get a pretty good explosive. Not as good as the other two that I showed you, but it does work. Here we have ammonium nitrate wrapped in a bag. The orange cord that you see there is det cord, so it looks like an extension cord, but instead of having copper wire down the middle, it has explosives. And they make a knot, put that in with a bag of ammonium nitrate, and again, automatic transmission fluid, and then they riveted this box together and put, these are rare earth magnets, hard drive magnets. What's really interesting about those is that they're so strong. With those 3 magnets, you put it underneath a vehicle or on the side of a vehicle, it's not going anywhere. They stay really well. This was a challenging set of devices to work on because of the containers were so robust, but we got through it. Here are a couple of examples of ammonium nitrate and aluminum powder. The one on the left actually is really clever in that they take an aluminum paste that is used to make metallic car paint and then mix that with ammonium nitrate prills, and voila, you have an explosive. On the right, they ground up the ammonium nitrate prills and mixed it with an aluminum powder that's most commonly used in fireworks. And they look a little bit different, but their performance is basically the same. Grinding up the ammonium nitrate prills improves the performance, but they work nonetheless. Here you see a closer look of the paste. If you ever break open an Etch-a-Sketch, the kids' toy Etch-a-Sketch, they use this type of aluminum powder. It's almost like little sheets of aluminum, but just very, very tiny. And here we see the same ground up ammonium nitrate and aluminum powder mixture. They actually had 2 5-gallon containers mixed with this. They had a commercial blasting cap that you see here, and then that is attached to appliance wire. So those 2 combined were probably on the order of 45 kilograms, would be my guess. It was in the trunk of the car. They hooked up the appliance wire to the stereo speakers, and the way this device worked is they roll up to their target and simply turn on the stereo. No special switches, lights, gadgets, or anything like that. You just turn the stereo on. I'd like to bring this mixture up when I talk with first responders, because I don't want you to learn about Armstrong's mixture for the first time in a real incident. What you see here in the bottom is Armstrong's mixture that I pulled out of a blasting cap. Probably one of the dumbest things I've ever done, but I learned a lot from it, and I kept my fingers. You make Armstrong's mixture quite simply by scraping off the striker on the side of a book of matches. They can't be strike anywhere matches, but you understand what I'm saying. That striker is made up of red phosphorus. Red phosphorus mixed with potassium chlorate is extremely sensitive. If you think about cap guns, the kids' toys cap guns, that's what that is in there, or the little snap pop things that you throw on the ground. That's Armstrong's mixture. This particular case, they were using Armstrong's mixture to convert non-electric blasting caps into electric blasting caps. This stuff is extraordinarily sensitive. It can be green, it can be reddish, but if you find something like this, absolutely do not mess with it. Don't touch it. Please do not try to make this at home. You can hurt yourself very badly. It is extremely sensitive. Okay, how do you store and handle your training aids? This is really important. If you do not store and handle your training aids properly, you are probably going to either put your odor on it, in which case the dog is now searching for you, or you're going to cross-contaminate, in which case the component that has the highest vapor pressure is going to be most dominant, which may lead your dog into not looking as thoroughly as what they should. Let's talk a little bit about vapor pressure. Vapor pressure is essentially whatever is off-gassing. I like to think about a Coca-Cola bottle, and the fact that when that thing comes from the store, you open it up and there's that really hard hissing sound. That is based on the vapor pressure of the carbon dioxide trying to escape from that solution. It will fill to a certain pressure based on whatever your material is, and then it can't do any more. So what's important about vapor pressure is the higher the vapor pressure of whatever your explosive is, narcotic, whatever it is that you're working on, the higher the vapor pressure, the more it's going to off-gas. And the more it can dominate other odors that might be present. If you use a lot of air void in between the level of your explosives that are in the container, your explosive is going to off-gas and fill up that air void. We call it headspace. It's going to fill up that air void until it reaches equilibrium, until it reaches whatever its vapor pressure is. So if it's a tenth of a PSI, then it's going to fill it up once it reaches a tenth of a PSI. As soon as you open up that container, it's going to off-gas. Moral of the story is that you're going to lose material each time you open the container, as long as the container is significantly bigger or larger than the volume of your explosives. And here's an example of that. So the ideal storage configuration is an absolute minimum headspace volume. You want the smallest possible container to contain your explosives or whatever it is that you're working with. People think about TATP and how fast it starts to go away. I've had samples at New Mexico Tech where we kept TATP around with no loss of material for a couple of years, all because we stored it in a certain way. We minimized the headspace volume, and then we did a couple of things that I'm about to talk about. The big thing about storage, aside from headspace volume, is what is your container made from? If your container is made of some type of organic matter, for example, plastic bag, Tupperware container, anything that is not glass or plastic is probably going to be an organic. Over time, organics will always pass through other organics. It's just a matter of time. It also depends on, again, the vapor pressure, the type of explosive you're dealing with, heat, humidity, barometric pressure, all those things, but eventually it will pass through. An inorganic storage container like metal or glass will not allow for those materials to escape. So if you have a glass jar with a metal lid, or you have something like a paint can where you can form a good seal, those things are excellent for being able to store your materials without anything leaking out. That means that it's not going to cross-contaminate with something else that's also stored in an organic container, and you're also going to keep your material a whole lot longer. So we really stress minimal headspace volume and an inorganic container to maintain your odors. Here's an example of how we store ours. We have on the inside of this, we'll either have a glass jar with a metal lid, and then probably an anti-static bag, or just the anti-static bag, depending on what the material is, because static is not our friend when we talk about explosives. We have a product called the Odor Print, and the Odor Print takes very small amounts of explosives, maximizes the surface area to give you the most available odor possible. These things work exceptionally well, and they last for a long time. When I say a long time, we can go 6 months to a year, depending on how you handle them. When we talk about storage and handling, it's important that you never use your bare hands. When odor prints are made, we never touch them. From the time that those aluminum discs come from being laser cut, they're never touched by human hands. So we always wear gloves, or they're never touched by human skin. So in the entire process, we always wear gloves, whether it's putting them together, packaging them, everything is done with a gloved hand. So there is not a unique Todd odor to it. And we go put them in metallized Mylar bags. So if you think about like when you open up a bag of chips or crisps, then you'll see the foil type container on the inside. If you notice, you don't smell what the contents are until you open the bag. Same concept here. That inorganic metal lined bag is what helps keep everything in. Plus the bag collapses around the odor print so that there is minimal headspace volume. And for those reasons, we're able to keep the odor prints intact. We have some that have been in the field for a year, and the dogs are still smashing them just like they did when we first sent them out. We've started now double bagging just to make sure that we have the best possible enclosures. On the homemade explosive side, we have the mixed odor delivery device, and it is a device that was created by Naval Research Lab to mix homemade explosive odors without actually making a homemade explosive, because nobody wants to deal with it after it's mixed if that's not the goal. So what we've done is put together a recipe book along with all the chemicals necessary for you to put all those fuel and oxidizer mixtures together, like what we discussed earlier. put them in the mixed odor delivery device. They don't come in contact with each other, but because no chemistry takes place, you get a nice plume that basically stays around where the opening is that you see on the top here. And your dog doesn't come in contact with odor, or doesn't come in contact with the chemicals, but they get a good mixture of those odors in target odors of interest. The big key with these is definitely the oxidizers, as we discussed earlier, because the possibilities are virtually endless on the different types of fuel oxidizers that you can make. The odors that we've selected, the fuels and oxidizers that we've selected are all based on real world incidents. So this isn't just a chemist nightmare. This is just this is the stuff that's been used. So you should definitely pay attention. All right. I hope I didn't go too fast or go too in depth with chemical names. What questions do you have? Any questions?
Tyler, I've got one. So I've got one of your mini mods. And when you open the case, it's got all the different oxidizers and potassium chlorates and etc. For making up your own HME for training. So my question would be is how many different alterations really can I make from this in regards to current HMEs being used out there?
I would say I haven't looked at the recipe book in a while, but you can make probably over 50 different mixtures. And the reason why I say that, the top row is basically made up of hydrogen peroxide, concentrated hydrogen peroxide mixtures. Then you have potassium chlorate and ammonium nitrate. And I kind of put them in that order on purpose because it's in the descending order of how aggressive those oxidizers are. But just because they're in a specific row doesn't mean that you can't mix them with others. So for example, Poor Man C4 is potassium chlorate and either paraffin wax or petroleum jelly. Well, I can definitely take ground up ammonium nitrate and mix it with those two and get the same type of results. So as long as you mix and match those fuels and oxidizers, the possibilities are almost endless. But the recipe book that comes with it, again, goes through recipes that have been used by bad guys, and we reference exactly what those incidents were. But you can always play around with them and mix them in different ways. And basically, almost all of them will work. There are a couple of exceptions, but almost all of them will work.
Thanks for that. That's awesome.
Talked about the GSR odor print. Have you had conversations with folks about that? And the reason why I'm bringing up the GSR odor print is we're actually going to file a patent tomorrow in the United States for the GSR. And the reason why we're doing that is, for one, we've got competitors trying to steal everything we produce. But we have a really unique combination of those stabilizers. And there's a canine team here in the States that has the record for the largest illegal weapon seizure in the United States. And that dog is imprinted on those chemicals. And that's why we chose them. Not to mention the fact that when we do research, we use Google Scholar and use things like Forensic Science International articles on concentrations of things in headspace and what happens to different explosives and that sort of stuff. So it's not trial and error. I mean, we actually work really hard to make sure that these things are well researched. So if there's any need in your region to find weapons and shell casings, that is absolutely the thing you want to imprint your dog on, is that GSR odor print.
Well, does anyone else have any questions for Todd while we have him here?
Well, I hope the information was beneficial. If you have any questions, please feel free to contact us. You have the contact information here, or contact Wayne, and we'll do our best to answer the question for you. We're pretty much available, well, I won't say 24 hours a day, but at least a good 18. So we really try hard to make sure that first responders and people who are out there at the forefront get all the information they need and get it quickly.
Well, thank you everyone for coming, and we will turn it off here. Thanks, guys.
Thank you.